Hi, hello, namaste, how are you all? Let's start the session with the beautiful affirmations. So what's today's affirmation? I'm becoming more disciplined, balanced and focused. I'm becoming more disciplined, balanced and focused. And naturally work what truly matters. What's the second one? And naturally work what truly matters. I just want you to repeat along with me. I'm becoming more disciplined, balanced and focused. And naturally focus what truly matters. So let's start the session. So what will be there in today's session? So I'm going to do the complete model paper 1, complete solution for the model paper 1, which is released by the PU board. Okay, let's start the session. That's going to be model paper 1. So what's the first question? So first we will be doing the MCQs. Select the correct answer from the choices given below. The exception raised when the requested module definition is not found. What is the question? The exception is raised when the requested module definition is not there. Very simple. SQRT we have taken, but the respective module only is not defined. How will I call SQRT? It is through math function only, math.sqrt, but the module itself, but the module itself is not present, means it's going to be given the error as an import error. That means what I have to do? I have to write import math, and then I have to call math.square root, right? I have to write math.square root, right? But here the module only, if it is missing, if the module only is missing, definitely it's going to give an error. What? Import error. Very simple. Any error related to the module means it's going to give an import error. So how are you going to write the MCQs in your paper? So you're going to write the answer as 1C import error. Okay, and then there is another question here. I have told you this multiple error, import error. Okay, and after that you're going to give a space and then write D. That's considered it's going to be keyboard, something like this. So you're supposed to give one line space and then continue. Is the point clear? So let's go with the next question. The method which is used to convert Python objects for writing data in a binary file. So we need to write the Python objects to the binary file. Okay, we have to store the Python objects, means definitely it should be a binary file only. So who is going to help us? Pickle is going to help us, the module. Within that pickle we have two functions. One is going to be the dump function, another is going to be the load function. For storing, for writing, very simple, it's going to be the dump function. Is the point clear? So we'll go for the next question. Assertion, a stack follows LIFO. Stack of bangles, it follows LIFO only, last in first out. Okay, and then what do we have here? Okay, so they have given you this as wrong, so this should not come. A stack follows a LIFO rule and insertion and deletion takes place at the same end. Insertion takes place from this end only, and removal, or it can be deletion, takes place from the same end. We call it as on top of the stack. Definitely this is also true, this is also true. So what is the answer? We have to select A. We have to select A is true and R is the correct answer, right? So we'll go with the next question. What is the next question? Deque is a version. How you need to pronounce this? This you need to pronounce as Deque. Deque is a version of a queue which allows insertion and deletion at what? See, Deque I told you. So what is Deque? Deque is basically a version of a queue wherein it's a modification of queue only, wherein we can do insertion and deletion from both the end. Okay, this is the answer. Okay, fourth one, C is the answer. In bubble sort while sorting in ascending order, which element reaches its correct position after the first pass? Okay, which element? For example, if I write 5, 4, 3, 2, 1. Okay, if I write 5, 4, 3, 2, 1, then how the comparison goes? It goes like this. Then it will be 4, 5, swapping is going to happen. Then it's going to be 5, 3, swaps. Then this. 4, 3, 2, 5, 1. This. Understand that at the end of the first pass, the largest element is in its place, in its correct position. So the answer is the largest element. So what is the question? In the bubble sort, while sorting in ascending order, which element reaches its correct position after the first pass? If the first pass, for the pass 1, okay, the largest element is sorted out. So largest element is the answer for this question. Okay, we'll go with the next question. In selection sort, the smallest element is selected in each pass and placed in its correct position. They're telling the smallest will be selected in the pass 1 and it will be placed in its correct position. And what is the second one? In selection sort, the nth element is the last and it is already in place. Okay, we'll try to understand this. So we have 4, 5, 3, 2, 1. Same thing I'm going to consider. Selection sort, what happens? The minimum will be selected. How minimum? So I'm going to assume this is the minimum. Then I'm going to compare. Then definitely this becomes the minimum. Okay, 5, 4, 3, 2, 1. This will become the minimum. And then I'm going to compare these two now. 5, 4, 3, 2, 1. This will become the minimum. And then what do? 5, 4. This I'm going to compare. Then this will become the minimum. M is the minimum, and after this these two will be compared. 5, 4, 3, 2, 1. This becomes the minimum, especially the position we're going to take it. After this, what do? We're going to swap the first element with the minimum element. First element with the minimum element. First element is what? With an index 0 only. That means I'm going to put here 1, 4, 3, 2, 5. What is it? In the selection sort, the smallest element is selected in each pass and placed in its correct position. This is going to be the pass 1. This is going to be the pass 1. So it's absolutely right. This is right. In selection sort, the nth element is the last and it is already in place. Which is the nth element? Okay, let's consider it's going to be the last element. Last element, will it be placed already? Definitely not. So this is going to be false. This is true, this is false. So what is the answer for this? A is the answer. A is true, B is false. Clear? We'll go with the next question. The number of attributes in a relation is called. What is a relation? Relation is basically a table. So the number of attributes in a relation is called as degree. Okay, number of attributes in a relation is called as degree. Is called as degree, you need to remember. So what are the attributes? Let's consider it can be name. In a table means name of the student. Then we can have percentage. Okay. Then we can have an average. Then we can have marks. Okay. Then what we can have? We can have a phone number, and then we can have email ID. So many attributes. So these are all called as the attributes. The number of attributes for a relation or a table is known as a degree of the relation. The most popular query language used by RDBMS. Which is the most popularly used language? That's going to be MySQL. Okay, structured query language. Which of the following is a string single row built-in function? Single row built-in function string. So it's going to be related to string. I think it's very simple. You can just write down. It's with respect to the SQL. It is length. Not len. Len is a Python function. Length is an SQL function. If they give between length and len, most of us will get confused. So ensure that length is going to be SQL, whereas len is Python. Clear? So length is going to be the string function, single row function. 10th question, the operation is used to combine the selected rows of two tables. So there is a table here called a music table. That is what you would have seen in the textbook. A music table, and there is a dance table. I need to combine. There are certain students who are participating in the music table. Okay, music table means what you can have. You can have a name of the students and how many of them are participating, what is their interest, everything related to which song they are singing, all those things you can have it. And there is another table called dance table. So the tuples from this table and the tuples from this table, tuples means the rows only. Tuple means to say that it is going to be the rows only. If you have to combine both the rows of both the tables, we're going to make use of union operation. It's a set operation, union operation. When this intersect will come, common tuples. When there is a common tuple, then we'll have this intersect. Minus means what? It's like one table rows, if it is minus from the other table, then you're going to have minus. Product is Cartesian product. Okay, I'm going to combine all the tuples in all the possible ways. That's going to be product, especially the Cartesian product here. Okay, so let's start with the next question. That's going to be 11th question. So what do we have? Correct expansion form for HTTP. Hypertext Transfer Protocol. What? Hypertext Transfer Protocol. Okay, network topology where data can be transmitted only one direction. Okay, so they have given you many topologies here. Okay, the arrangement of nodes, the arrangement of computers in the network is known as in topology, in which topology there is only one-way communication. Okay, so the example is going to be a ring topology wherein the nodes are connected in the form of circle. If I consider these other nodes, it will be transmitted only one direction. So the example will be a ring only here. Mesh topology, both the way communication, that means it's bidirectional. Even in bus also it's bidirectional. In case of star also bidirectional. Okay, way the communication can take place. We'll go with the next question. The example for half duplex communication. What is half duplex communication? That means there is a sender here. Okay, there is a sender here A and there is a sender here B, and the communication has to take place between both in A and B, but one at a time, not simultaneously. A can also transfer, B can also transfer. A can receive, B can also receive. Both A can act as a sender and receiver, B can also act as send and receive, but only one at a time. Okay, if this particular client is speaking and he has to listen, if he is speaking he has to listen, not simultaneously they can talk. So example for that is going to be walkie-talkie. Okay, simultaneous, but simultaneous communication will be full duplex. One at a time. Both can act as a sender and receiver here, but one at a time. So remember that example is going to be walkie-talkie. Another question will go now. So communication protocol which establishes a dedicated and direct connection between the two communicating devices. For example, there are so many nodes in the network. Okay, and there are so many ways through which it is being connected. So now, for example, A has to communicate with B. There may be multiple paths. Okay, there may be multiple paths like this. There is another node, let's consider. There are multiple paths, but there may be a direct communication between A and D. Only this route it will send it. A direct communication. It's highly secured. So that is called as point-to-point protocol. A point-to-point protocol is basically a protocol wherein there is a direct dedicated connection between the two communicating devices. That's called PPP protocol. That is point-to-point protocol. 15th question, the standalone program that are capable of working on its own. Host is not required for the functionality of that particular malware. So example is going to be worm. That means it is independent. No motivation is required for it. It can do it on its own. Okay, so that is an example for worm here. What is worm? Worm is basically one of the type of malware. It doesn't need a host for it to function, for doing its like whatever the task has been given, whatever the program it has been written. No, for it to function, for it to execute, there is no requirement of a host. It's a standalone program. Of course, it's malicious only, but it's a standalone program that are capable of working on its own. That's called as worm, right? We'll go to the next question. So what is there in the next question? That's going to be the fill in the blanks. We have done with all the MCQs. 15 are done. So we will start with the fill in the blanks. So what is the first question? The first question is going to be dash statement in Python used to test an expression in the program code. Okay, to test an expression in the program code means, see here, it's basically with respect to the exception handling only. Maybe you may find it difficult to, because there is no exception concept only here, you may get confused here. They're asking you a dash statement in Python used to test an expression. Testing an expression means when condition come, in that condition, if the condition becomes fail, then assertion error rises. So here, if you can see here, rise and assert, both they have given. In RISE also, when you are doing it, you may put some condition, but not compulsory. It's not compulsory. Simply if you raise exception will be raised manually. Assertion, in order to raise an assertion error, they need to have a condition. We need to have a condition, only then assertion error will be raised. So testing a condition means you can opt only for this, not this. Rise will never come into picture here. So assert is an answer for this question. Okay. And after this, dash file consists of data stored as a stream of bytes. Stream of bytes. Plain text means text file. It's going to be a stream of bytes, means the answer is going to be the binary file. So we have answered this. We have answered this. This is going to be 16th and this is going to be 17th. Each row of a table is called what? Each row of a table. So there is a table here. I've written Ram's record, and then we have written Shyam record, and then we have written Krishna record, and then we have written Radha's record. All these things are called, we call it as a tuple, row, or a record. So in this case, they're asking you each row. Record is the answer. That's going to be 18th one. Record is the answer. Okay, record is the answer. We'll go with the 19th question. Dash is a command which comes under DML. Dash is a command which comes under DML. DML is going to be what? Data manipulation language. Under data manipulation language, if you can come across with all other options, max is there, attribute is there, insert is there. If you look at carefully, insert is a command and these are all not commands. This is going to be a function, and attribute is a keyword here. So keyword means, especially with respect to the SQL, not as such a command as such, right? So we have an insert here. So insert is going to be what? It's going to be a DML command, that is data manipulative language. Dash is an aggregate function. Aggregate function means what? Which works on multiple rows. Single row function we have seen, no. Single row function, string single row function, length was there, no. Now they're asking aggregate function. Aggregate function means it's a group function which works on multiple rows, entire column it works, multiple rows or entire column. Example is going to be what? Max is an example for that. Max is an aggregate function. Okay, of the option you have to choose max only. Max, min, sum, count, these are all the aggregate functions. Okay, we'll go to the 2 markers now. So what is the question now? What is prefix and postfix expression? What is, I told you very clearly, what is an expression? Expression is a combination of characters, operands or operators and parentheses when evaluated results in a single value. Very simple expression. I'm going to take it x plus y. I'm going to take it. If I put the value of x as 5 and the value of y as 3, if I evaluate it, I'm going to get 3, no. I'm going to get 8, no. Ma'am, what are you telling? You're telling 5 plus 3 is 3. I'm sorry. 5 plus 3 is going to be 8. So what I'm trying to tell you is expression is basically a combination of operators, operands, parentheses. When evaluated, it results in a single value. It results in a single value. Is the point clear? So this is called as an expression. This expression can be a postfix expression. This can be a prefix expression also. Prefix expression is what? Prefix expression means infix. See, there are 3 types of expression actually. We call it as an infix expression, and we have a prefix expression and a postfix expression. Prefix means what? So first we'll understand infix. Infix means the operator is present in between the operands. In between the operands. That is infix. What is prefix expression? The operator comes before the operands. That means what, ma'am? Plus xy is an example for that. Plus xy is an example for that. What is postfix expression? The operator comes after the operands. That means xy plus is an example for that. XY plus is an example for that. So they have not given you example. It's better you give one definition and one example. That will be more sufficient. Is the point clear? So this is also called as in Polish notation, and postfix expression is called as in reverse Polish notation. Polish notation, reverse Polish notation. Even they ask you for 1 markers, no, all those things can be covered. That's the reason little bit more I'm explaining here. It's not that you have to write all the points what I told you. If you can write one definition, one example will always be better. Example is going to be a must. You can convey it very easily and very quickly. Very easily, very quickly you can convey what you know. We'll go to the next question. Write any two applications of queues in a computer science. So what is there? So queue is what? Let's consider that Ram has come to ask me the doubt. And then we have Radha. Okay, first Ram came, then Radha came, then we have Krishna, and then we have Shyam. These are the students, they came to ask me the doubts. First Ram came. After that Radha came, so after Ram only Radha can stand. If Radha bypasses and come, no, then I will say that you stand in a queue. That means insertion takes place from the rear end. Insertion takes place from the rear end. And deletion takes place from the, it's not this, deletion takes place from the front end. This is insertion. So if one more person, let's consider Keshava. Keshava wants to join this. Keshava also should join after Shyam, not before. Okay, not before Krishna, Radha, or before Ram also. It's not, I will say no, it's not possible. That's called queue. Insertion takes place from the rear end and deletion takes place from the front end. That's going to be a simple concept of a queue. And what are the applications of it? So simple queue is basically used for handling multiple user requests. So there is a server, there are so many clients. Okay, this client is, for example, Google. Everyone wants to search something on the Google. So he's also send message. He'll also send some requests. He'll also send some requests. So many people, keep sending requests for the server. So the server is also tired now. So how will it address? It will just address based on first come first serve basis. Okay, it's going to handle based on the queue. You have come first, I'm going to serve you. You have come later, I'm going to serve you later. Very simple. Job is solved. Handling multiple user requests. Job scheduling in a multitasking operating system. Job scheduling in multitasking operating system means very simple. If the let's consider an operating system, you want to get a Gmail notification, you're working something, you want to get a Gmail notification, and then you want to get something WhatsApp notification, okay, and then you want to do some word processor, okay, on word processor you want to type something for your project, and simultaneously you want to listen to the music. All these tasks you want to do it simultaneously, and at the same time you want to give a printout also. Exactly at the same time, few nanoseconds or picoseconds, there will be some differences, right? You click this, you click this, it will take some time for you to click the next application, right? All these jobs, I call these as jobs only, I call it as a process. Actually, what is a process? All these applications, all these jobs are basically put into a queue. All these jobs are put into queue. What, ma'am? Everything is opening simultaneously. We cannot feel that it's being opened simultaneously, but the processor is actually get few seconds for this, few seconds for this, few seconds for this. It allocates on a round robin fashion. Few seconds it will allocate. It will do for Gmail, it will give some 2 seconds. It will for this, it will give some seconds. It will give for some second. Depending on the requirement, it's going to time schedule it. But we will get it that everything is taking simultaneously. Multitasking also going to work based on queue. Everything will put into queue one by one. Little time it will allocate. That's the point here. So in detail we'll be explaining about this concept in the coming videos. Okay, that complete revision is there. There I'm going to explain in detail along with one example called dosa example. I'll give that example for you. Okay, we have managing multiple print requests in printer queue. For example, I have given some 40 pages. Okay, I have given 40 pages. He has given 20 pages, and one girl, she has given 20 pages. Or one more, he has given 1 page. But I have given first, then it is going to print my file first, and then his, and then hers, and then it is going to be his chance. So like that, even print also works on queues only. Everything, whatever the jobs it gets, it is stored in the queue and on time, and based on the queue. So first come first serve basis, it's going to be served. Here, these are some of the applications of queues. So what is collision situation and collision resolution and hashing? Very simple. This concept can be explained like this. Let's consider 8 80, and then I'm going to take 32, I'm going to take 14, and then I'm going to take 35. Okay, these are some numbers I'm going to take it. This is going to be a list. See, I just want to search. I just want to search whether 35 is there or not. How will I search? Ma'am, it is there. Why to search? It is there. See, that's quick we are. Looking at the number itself, we can just tell where it is. Right? How we are checking? How did we check? I just checked here with each and every element in the list. Traversing. Is it here? Is it here? Is it here? Is it here? Yes, I got it. Searching is giving you the position only, no? Now, here we have to check every element. Now, I've just stored the element, randomly and keep searching every element. I've just stored the element randomly and keep checking every element. I've stored in index 0, I've stored in 1, I've stored in 2, I've stored in 3. Now, instead of that, you just store the elements according to some required criteria and then search for the element. What is that? I'm going to store the element according to the index, something called as an hash function. That means I'm going to have a table called as an hash table. In this, all these things is not required, just definition is required, students. It's more than enough. I'm going a little bit so that you can understand the concepts thoroughly. Okay, so please do watch the complete revision program so that in depth the concepts will be explained here. Here also definitely I'll ensure that I'll give you some idea here. Okay, but the video becomes very lengthy, so I can't continue for more time also here. So we have collision, that's what I'm trying to explain here. So we have 0, 1, 2, 3 are there. These are the indexes. I'm going to store 80 in the index 0. That means take a number. I'm going to store in the index where I get the reminder as and 0. That means what? 80 divided by 10. That means 10 8s are 80. Reminder is 0. Take a number, divide by 10 and check for the reminder. Okay, you will always get the last digit. Hash function is basically a function, especially for this case that is given in your textbook. Taking a number, divide by 2 and check for the reminder. Reminder is going to be 2. I'm going to store 80. I'm going to store here. And 32 I'm going to store here, and I have 4 here. Okay, I'm going to have 4 here. I'm going to store 14 here. I've got 5 here. I'm going to store 5 here. This is going to be none. I'm going to make it none. Store here in case of linear search. What did I do? I just stored the elements randomly wherever I wanted, and then I kept on searching each one by one. Here, no. I'm going to store the element in a place where I know the index. Store 80 in 0, 14 in 4, 35 in 5. That means based on the index value calculated by the hash function. Is the point clear? Divide by 10 and check for the reminder. I'm going to store it there. And now you tell me, where is 14 present? Very simple. 14 is present in 4. 14 is present in 4. If I give, let's consider 33. Where is 33 will be placed? That means take a number, divide by 10 and check for the remainder 3. I'm going to store it here, 33. And I'm going to give 11. I'm going to store it here. Very simple. Store the element and in the respective index calculated by the hash function. Problem is solved. No, the problem arises now. I just explained you how the problem comes. So what is the problem? What if I give a number as 30, okay, not 35, 25. I give a number 25. This is also going to be 5, reminder 5. This also comes the reminder 5. If I take it as, let's consider 14 is there. No, one more, I'm going to take it as 74. 74 also, 74 divided by 10, what will I get? Okay, 7s are 74. For 74 also I have to store in 4 only, and then for 14 also I have to store in 4 only. There arises a collision. That means what? Very simple. When multiple elements are mapped to the same location in a hash table is called as collision. When multiple elements are mapped to a same index, same address in the hash table, this is called as a hash table. It becomes called what? It leads to collision. A technique used to handle and store multiple data items that are assigned to the same address. A technique to solve A technique to handle or solve whenever the multiple elements are stored in the same address, hash address calculated with the hash function in the hash table, we call it as a collision resolution. Solution for the collision is called a solution resolution. Okay, please do write it elaborately. Collision is when multiple elements having same address. Okay, a technique to solve that, the technique to handle this collision is basically called as collision resolution. Clear? So we'll go for the next slide. So what is there in the 24th slide? Write the rules which are imposed on an attribute of a relation. So we take a relation now. What is the relation? Relation, I told you relation is going to be a table. Okay, relation is basically a table. We'll take a simple name. I'm going to take a table as in student here. I'm going to take a name as student. Okay, we have a name here. Okay, I'm going to take a roll number. Okay, and then I'm going to take their email ID, and also I'm going to take their phone number. Okay, I'm going to take their phone number. Okay, these are called what? Tell me now. You have to tell me. Attributes. Total number of attributes in a table is called what? What is that, ma'am? Total number of attributes in a relation, I heard somewhere. That is called degree, student. Just now you read, no. Total number of attributes in a relation is called as a degree. Remember that. It's called as a degree now. Now they are telling that each attribute in a relation must have a unique name. This should be unique. Name I can't keep. Roll number I can't keep. It should be unique. The order of the attributes does not matter. I can put roll number here, name here, email here, and then I can put phone number. The order of the attributes in relation does not matter. These are the rules. Remember that. We'll go with the next question. Write the difference between char and varchar data type in SQL. So what is char and varchar? Char represents in character and varchar represents in variable character. Char is a character and varchar is a variable character, fixed length character data type. That means if I write, let's take an example as name char 30. Name char 30 I'll take, and name varchar, name one varchar I'll take 30. This is also 30, this is also 30 means, for example, I just want to store Shilpa here. If I store Shilpa here, then what happens? All 30 bytes of data will be allocated for that. Fixed. It's fixed. If you're using or not, it's going to be, for example, 6 characters are there and rest of them will be filled with a, so that's going to be, let's take 0, 1, 2, 3, something like that till 29. Okay, you can take it from 1 to 30 also. Okay, in SQL and all, it starts from 1 to 30. So whatever it is, whatever the number of characters it is used, and later which is not used, it is basically filled with a blank space. But it is occupied. In case of varchar, maximum allocation can be 30, but what I've used is only 6. But what I've used, my name taking is only 6 characters, so that will be only 6 will be allocated as and when the data comes. As and when the data comes, the allocation takes place. Maximum it can take 30. That means 30 characters I can give it. But allocation is actually taking as 6 only. Dynamic allocation. As and when the data comes, I'm allocating. As and when the data comes, it is allocating. That is the best technique. That's the best data type. That's the point here. Memory efficient data type, I can tell you. So, okay, always uses space for the 10 characters. Varchar use space only for the entered characters. Only the actual number of characters are stored here. Unused spaces are padded with the blank spaces. Clear? So, we'll just go with the next slide now. Mention any 2 network devices. What are the network devices we can have here? So we have a modem, hub, switch, repeater, router, gateway, Ethernet card, or NIC. NIC is what? NIC is going to be network interface card and RJ45. Okay, recommended. Okay, athwa radio jack also we can call it. Okay, that's called radio jack 45. These are basically some of the networking devices. Anyway, they just told you to mention. You can mention any 2. Just write around 4, so that will be better. We'll go with the next question. Define data and communication. So what is data? Data is going to be the raw facts and figures. It can be in terms of symbols, text, numbers, images, audio, video that convey the meaning. See, if I write, for example, I'm going to write my name. Okay, I'm going to write my name, and I'm going to write something as, let's consider, what is that I'm going to write? CS, I'm going to write as teacher. Okay, I have written as CS, Shilpa, teacher, something like that. It doesn't make a sense. But if I frame it, if I process it, that becomes information. That does not carry meaning. Actually speaking, it does not carry any meaning. See, actually, it's all the raw facts. Just with the data, no, we cannot have any kind of conclusion, or decision making is not happening. But when it converts into an information, only then the decision making happens. That's why we call the process data as information. It doesn't carry meaning. Actually, it is wrong. It doesn't carry any meaning. It has a raw facts, everything is there. You have got 70 on 70. 70 I have given. What is 70? We don't know. In CS, you have got 70. It carries some meaning. Right? Process data is called information, and we can actually make some decision only based on the information, not on the data. That you keep in mind. And what is communication? Exchange of data between the two devices or the two parties is known as communication. What is communication? Exchange of information between the two parties or between the two devices is called as communication. Now you tell me sincerely, is it communication I'm doing, or I'm just passing the data? Communication or data? I'm just sending one way, tuck, 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 tuck. Is it a communication? I want this video to be actually communication. Please do comment. Please do, put your post your reviews or whatever you want to do. Any doubts, please do that, so that there is a scope for improvement always. Clear? So we'll just go. So what we are doing, it's a communication, not just data. Is the point clear? Next, we'll go for the question that's going to be answer any 4 questions. Each question carries 3 marks. So what is this? This is going to be based on exception handling. What is an exception? You already know it's going to be a runtime error that disrupts the normal flow of execution. What is exception? A runtime error that disrupts the normal flow of execution. So why do I need an exception handling? Why should I solve these exceptions? Basically to have a normal flow of execution, so that I can have a normal flow of execution. Okay, free flow of execution should happen. That there should not be any kind of abrupt termination should not be there. Okay, abnormal termination should not be there. It's actually going to divide or separates the main logic from the error handling code. You know that exception, how do we handle it? Try except block only, no? So this try exception handling code will be different from the main logic, so that clearly we can separate it. That's the main idea here. Okay, different types of exceptions can be handled, different kinds of exception, zero division error, value error, and we have another error called LIFO error. Whatever the different kinds of error, no, everything can be handled very smoothly with respect to the exception handling. That's the best part of it, right? Because one try block can have multiple excepts block, right? And to help interpreter locate and manage the errors efficiently. That's the ultimate thing. Okay, of course we can encounter. That's why we anticipate the errors and try to, avoid it. Try to avoid it. If it comes also, how to overcome in a smooth way without any abrupt termination. That's why an exception handling is required, right? So we'll go to the next question. Explain any 3 file opening modes. What are the different opening modes? I think we have just seen. We have a function called an open function. In this open function, we have a file name called sample.txt. Okay, and this particular file has to be opened in any of the modes. And this open function will always gives what? Open function always gives something. What does it give? It gives one pointer where you can handle your file, to read it, to write it, to append it, right? So what does it gives? It gives file object. What is FO? FO is in file object. Is the point clear? To call any function, you need this file object. What they are telling, what are the different kinds of mode? What do you do? Whenever you open a file, what do you do? You tell me. Are you going to read it? Are you going to write it? Or are you going to append it? So these are the different modes we have. Read mode, read only mode. RB opens the file in the binary mode, read only binary file. Okay, binary file only we can read it. Then we have R plus or plus R. Remember, plus means both read and write. Either it can precede or it can, okay, it is suffix or prefix, whatever it can be. Then we have WB plus. W is for writing. WB plus means what? That's going to be writing into the binary file. Writing into the binary, plus is there, no read. Read, write the binary files. Read, write the binary file. Read, write binary mode, in the binary mode. Okay, so after that, okay, overwrites the existing file or creates a new one. So when you're open the file in the write mode means if it's already there, it overwrites. Remember the difference between W and A. If you open in the write mode means it actually, if you're opening for the first time, means it's going to create a new file. You can start writing. For example, I've just written, hi students, hi, hello, namaste. Hi, hello, namaste. How is the energy? Is it good? Good. Okay, drink some water, we'll have more energy. So we have hi, hello, namaste written into the file. Now what we have to do it, this, if it is opened again, there is a file called sample.txt and there is a file called sample.txt. In this file only, I have opened it again for the write mode. Then what happens? So it will be written as hi, hello. That means on this only it will be overwritten. Okay, let's consider, I'll show you to here. Okay, there is something called hi here and I have to write it as hello. If I'll open the same file in the write mode again, I've opened a file in the write mode and wrote hi. Now the same file is opened, again in the write mode only means it will be overwritten. Ma'am, I want hi, hello, you tell me how do we do it. After hi, hello should come. After hello, namaste should come. After namaste, how are you all should come. And after how are you or how is the energy should come. Like this only you should come, you tell me. For that, you have to open a file in the append mode, not in write mode. Once it is open, no, you have to open that in the append mode. This should be an append mode. Okay, this is append mode. Okay, either you can read and write both. Okay, read and write. That means you can also, append it to the end of the file. Is the point clear? So this and all we have taught you. We'll go with the next slide. So what is the question? Define three types of algorithms we have there: constant time algorithm, linear time algorithm, and quadratic time algorithm. Okay, so in this, what do we have? Algorithm is basically what? It's a step-by-step procedure to solve a given problem. Okay, if an algorithm consists of no loops, there is no loop only in that algorithm, we call such algorithm as what? Constant time algorithm. That means we have a number of instructions fixed. So those instructions will be executed once and done. The time complexity is going to be 1 for such algorithm. What are constant time algorithm? Algorithm without any loops, time remains constant. The time complexity is going to be 1. And what is going to be a linear time algorithm? A linear time algorithms are having a 1 loop wherein the time grows linearly. That means the time complexity is going to be n. The time complexity is going to be n in this case. What about for quadratic time algorithm? In this, the algorithm will have a nested loop. What is nested loop, ma'am? A loop within a loop. Do you remember in your previous class, first year we have a nested loop. One example is pattern based, a loop within a loop. Okay, that example you can just recall. An algorithm with nested loop. So many we have nested loop also, no? Now also, like all the sorting techniques and all, we have a loop, nested loop only, right? So algorithm is nested loop, time grows n square. That means the time complexity will be n square. The time complexity will be n square. Clear? So we'll go with the next question. What is there for the next question? Write an algorithm to search an element using a linear search method. Very simple. I just gave an example only. Let's take an example 8, 7, 2, 5 and then I'm going to take it as 4. I just want to check 7 is present or not. What is it? It's going to be linear search. What is searching? Finding the presence of an element in a list. If it is present, where exactly it is there. What is linear search? A linear search is going to be a searching technique wherein is a searching technique. We also call it as in sequential search. Okay, that means we keep searching the element one after the other. Okay, wherein each and every element will be checked. Is the point clear? A linear search is basically finding the position of an element Okay, if the element is there, where exactly it is there. Searching means to find the position of an element only. Where exactly? Index you have to give it. Is the point clear? Now I have to search 7. Visit 7 is there or not? Ma'am, 7 is there only. Why you have to search, ma'am? You have to search. We have to learn this. What we have know it without actually calculating, without, see, we have to write it down each and every step what we are doing it without knowing. Just look at that 7 is there. Just look at that 2 is there. I need not have, so quick we are, right? But now we have to write it in form of code. So is it there here? Is it there? Is it there? Is it there? Like that we have to check one by one. We have to check. We need to do the traversing. That means every time I'm telling it is there or it is there, it is there, means definitely I need a loop here. From where I have to start? I have to start. Remember that searching definitely takes, a linear search definitely takes a loop here. Loop. Which loop? We are writing the algorithm. Algorithm means it's fixed that they are using while loop only. That means for loop also can be used, but on your textbook they have given while loop only. Let's follow while loop only. While loop, how do we write? While condition will have an initial value here, and we can have some statements here, and then we'll have increment or the decrement here. This is the syntax of a while loop. Remember this. So I have to start searching from the beginning till the end. That's why the value of I is equals to 0, I is less than n, and repeat steps. Keep checking every time. Check. Check means what? Repeat only. No. So repeat step 3. What I have to repeat? If I'm going to take the list as L. Simple. Okay. If L of I equal to the key element. Okay, if L of I equal to key element. What is key? Now, right now my key is going to be 7. I want to search 7. Is it equal to? Is 4 equal to key? If it is there, then say it is the element found at position I plus 1. Will you say the element, for example, 4 I have to find out. Will you say the element is present at 0? What is that 0? Can't you not understand? It is the first element. Why you are telling 0? Programmers will know a little bit. But normal users, they'll understand this is the first element. Index, no, don't tell me index and all. Just tell me that it is present in the first element. Right? So that's why we'll do this I plus 1, because index starts from 0. Okay, element found at I plus 1. Then if it's found, what you have to do? Just say bye-bye. That means you have to stop it. Stop it. Okay, and again you repeat. For example, 4 equal to 7. Definitely not the case. It does not satisfy the condition. Else what you have to do? Increment it. Increment means what? It will become I equal to 2. I equal to 1, sorry. It was 0, no? Here we have checked this. And it will become 1. Is L of I equal to 5 equal to it is checking with 7. Is 5 equal to 7? Definitely not the case. It does not satisfy the condition. Next we'll go for the else part. It will be incremented. I'm going to check this. 8 equal to 7. It does not satisfy the condition. Again we go back and check for this. That will be 7 equal to 7. Yes, it satisfies the condition. Yes, it satisfies the condition. Then what do we do? Element found at position 0, 1, 2, 3. 3 is there in I plus 1. I found out. That's all. Come out. Stop. This is how the linear search works. Clear? Okay, so this is very important. Just write in terms of steps and then write all. It's better you follow the indentation, students. Okay, make use of small letter only, if, else and all, no print. These are all you need to make use of small letters only, so that you will have a practice of writing the program properly. Clear? So we'll go with the next slide now. What is there? Briefly explain the database schema, data constraints and data manipulation. So what is database scheme? Database schema. Database schema is basically the structure or the design of the database or the skeleton of the database, which comprises of what are the different tables, what are the different attributes we have, what are the different constraints, and what are the different relationship between the tables. Everything is perfectly given in the database schema. That's called database schema. Design, structure, skeleton of the database. What is the skeleton? And I'll tell you, ma'am. That is only table, which table, what are the data type, what are the constraints, relationship, everything, it will be there in that. Okay, so what are constraints? Constraints means walls, rules and regulations. Rules or regulations or restrictions that are given what kind of data that can enter into a column. What they're telling refers to the rules and restrictions applied on a column. That means, for example, there is a column called roll number. The roll number should not be negative. It should not be negative. It should not be null. Roll number, it cannot have null value. Some person has come, some students has got the admission, means he has to have a roll number. You can't say null. No. There are certain restrictions or rules that can be applied on a column. For what? For ensuring the accuracy and validity of data such as not null. Check constraint, unique constraint. Each and every email should be different. It should be unique. I can't have a repeated email ID here. No. It should be unique. It should be unique. And can it be null? There are so many people who don't have an email ID. It can be null, but if you have it, it should be unique. That means unique constraint. We can have a check constraint. That means marks should be between 0 to 100. That's it. You cannot have more than 100. You cannot be negative. We can't give negative marks in PU exam. So like that, certain rules and restrictions that are applied on a column for a particular column for ensuring what? For ensuring accuracy and validation of data is called as data constraints. Data constraints we call. So what are data manipulation? Data manipulation are basically the modification that can take place with respect to the records. What are manipulation? Modification of data in the database is called as data manipulation. What are the modification that can take place with respect to the data in the database? That means I have a data, I want to update the value. For example, our address was in, the address is in Talgatpur. I want to change it to some other address. I want to make it to JP Nagar. Address, I want to change it. Address, I want to change it. The data, whatever the data I've entered, I want to change it. I want to delete some data. And remember here, updating of records, deletion of records also comes under data manipulation. Not only that, this you can easily understand it's going to be manipulation of data. Even with respect to insertion of records also, that also comes under data manipulation only. Manipulation means modification. Modification means insertion. Insertion, you may think how, but remember, under DML command, data manipulative language command, under this we have insert, update, delete will come. Keep this in the mind. Clear? So we'll go with the next question. So what do we have? Explain different match single row functions used in SQL. What are the different match single row functions we have here? So we have a puff function, we have a round function, we have a puff function, we have a round function, and we have a mod function. What is this puff function? A puff function is basically, just exponent function. That means 2 to the power of 3. 2 to the power of 3 means you're going to get 8. So how do we write it? Very simple. There is a function called puff function. Simply if I write puff of 2, 3, it's a function, correct, but that we need to display it. No, how will we display it? Through a select function only. Through a select command. Through a select command. Definitely select is not a function. Select is a command. Select puff of 2, 3. It will give you output 8. Okay, and then what do you get? Round function is going to round off the value to 1 digit. They've given you as what? 1 digit. 2912.5641 is there, means I just have to check the next digit. This digit I have to represent. No, next digit you check. If it's 5 and greater than 5 means you just round off. 6 is there, it is greater than 5. What will I do? I'm going to round off to the next integer. This I will make it to 6 now. Can you come again? Definitely yes. What is that? We have 2912.564. No. How many digits? I have to round off to 1 digit. That means this I have to round off to 1 digit. Go to the next position. Okay. Next decimal point. If it's greater 5 and greater than 5, you just round off to that. So what is this? 6 is there. No, it's greater than 5. You just round off to 6 now. So it's going to be 2912.6. And we have something called mod. Remember here, there is a function called mod. Not this, don't get confused with Python now. So it's going to be mod is a function in SQL wherein it's going to find out the reminder only. No confusion in that. So how do you call it? Very simple. Select of mod. Select of mod 1021, 2. Select of mod 21, 2. That's going to give you what? Reminder only. No, 21 divided by 2. What is the remainder? Remainder is going to be 1. Output is going to be 1. Clear? So we'll go with the next slide. So what is there? Write a note on a local area network. So what is local area network? That's going to be LAN. It's very simple. There are 3 types of network. They may ask you any of these for 5 markers also. They've asked this question, students. You should be very careful in this. So we'll just understand what are the points that you're going to write for the LAN. Points are important. Simply, if you write the stories also, they'll not give. A valid point should be there for the LAN. Definitely, everyone is going to attempt this question, but valid point should be there. What are the valid points we can have for LAN? So LAN, we can have a coverage area. What is the area it is covering? Okay, coverage area, that means to say that what is the range with which it covered. Coverage area, what is this distance which it covered? That means to say it for 1 kilometer. Okay, it covers an entire building, the campus, and also with respect to the entire library. It covers the entire library, the entire campus. Okay, so this is going to be one of the point for you to write it. Coverage area, the range. 1 kilometer. It covers a distance up to 1 kilometer. Okay, 1 kilometer. What I can tell you, 1 kilometer area it covers. And after that, what are the different kinds of transmission media we can use it in order to have a LAN? That means we can use wires, Ethernet cables, fiber optics, and Wi-Fi connectivity we can have for the connection. And after that, you have to tell about with respect to the speed. So speed is going to be the data transmission rate. So it's going to be 10 megabits per second to 1000 megabits per second. And after that, why do we need a network? You write 1 point, you will get 1 mark. So why do we need a network? Basically for sharing of resources. Either it can be in terms of software, files, and definitely also in terms of hardware. For example, there are thousands of people. I can't have each printer for each one of the employee there. I can have some 2-3 printers and which can be shared among all those people, right? So these are some of the points you can write for local area network. We'll go with the next slide. Okay, we'll go with the next thing. That's going to be the 5 markers. So what do we have in the 5 markers? Write the applications of stacks in programming. What are the applications of stacks in programming? So before we go to the applications of stack, you should be knowing what is a stack. Now tell me, what is a stack? A stack is basically stack of bangles. This ma'am always gives stack of bangles because I feel it's very relevant. You can understand it very easily, and there is no chance for you to get confused. Okay, what is stack? Stack is basically a linear data structure where insertion of elements and removal of elements takes place from how many ends? Tell me. I have to insert the bangles, I have to remove the bangles. Okay, how many ends I have? I have only 1 end. Through this only I can insert, through this end only I can remove the bangle. Ma'am, what if we have some screw bangles? I'm not talking about that. I'm just only talking about the glass bangles. Clear? So we'll just go for this now. A stack is a linear data structure that follows a principle called what? Tell me what? Comment it. No, what is it? It's going to be LIFO, last in, first out. Last in, first out. That's the concept. So what are the applications of stack here? So we will have reverse string. For example, I just gave the example. Tack is an example. I need to enter tack. That means first I'll enter T. First I will enter T into the stack. I've entered a bangle called, I've added a bangle called T here. Okay, then I have added a bangle called A here. Then I've added a bangle called C here. Next I have to remove the bangles. Which one I'll remove? I'll remove a bangle called C. This bangle will be removed. Then A will be removed. Then will be T. That means what? I gave tack, it came cat. No, that means string reversal. That means it's a string reversal. Undo and redo operation. Let's consider an example. I want to have typed H in the word processor. I have typed H, and after that, then in the next, okay, next I have typed he, she, me, he have typed, and after that hell. What the hell are you doing, ma'am? What the hell am I doing? Do you want to say that? Yes or no? Okay, then I'm going to type H-E-L-L, hell. Want to say that? Okay, no ma'am, we want to say hello to you. That's nice. Hi, hello. Hi, hello. Hi, hello, namaste. Hi, hello, namaste. Okay, we'll just see here. So what is this? H-E, H-E-L, H-E-L-L, H-E-L-L-O. If I do undo, it'll come back to the state. If I do undo, it will come back to this state. If I do undo, it will come back to this state. If I do undo, it will come back to this state. If I want to redo, it will go back to this. That means, remember here, this is going to be based on stack only. First I typed H, no, it will be here. Then I have typed HE, then I have typed HEL, then I have typed HELL, but number of undos will be fixed. That you have to keep in mind. Number of undos and redos will be fixed. Okay, so this is another example, and we have web page navigation. Okay, first thing is that I want to watch some video on the YouTube. So we have a YouTube channel and I want to watch your video only. I want to watch, ma'am, you want to watch my video? Very nice. So kind of you. So YouTube I have watched. Okay, one video I have watched on YouTube. And after that, I want to see, it's enough. I want to watch some series. Okay, I just forgotten. Let me watch some series on the Netflix. And after that, let me search something Google also. No, in Google also I want to search something. Okay, I want to search something on the Google. Now, which is the recently visited web page? That's the Google. And next recently visited web page will be the Netflix. And then Netflix, what did I write? I have wrote this network. See this network, everywhere it will come. Netflix. And then we have YouTube. That means first I searched YouTube and then Netflix and then it's going to be the Google. Recently visited will be what? Google only, no? So it is also using the same concept, that's going to be stack only. Parenthesis matching. For example, let me erase this part and then I'm going to do it. So parenthesis matching means what? For example, I have written x plus y. And then we have z plus z star 8. So it will match how many? I have opened two parentheses here, two left parentheses are there. Means two right parentheses should be there. If it's mismatching, it has to give an error. What kind of an error? It's definitely going to give an syntax error. So such type of errors, it's definitely able to give by the interpreter with the help of stack only. I have this expression, it is difficult for me to do it because the interpreter should remember everything. The priority of the interpreter is everything. It has to remember and it has to give out the result. Expression means it has to evaluate only, no? So for that will have to be the interpreter, it will be easy for it to convert into postfix expression. If the same infix expression, if it is given in terms of postfix or prefix, it is easy for it to evaluate, not for you and me. We know to do it very easily through infix. But for we have to make the system work. No, we have to make our job easy. We will tell others to do it, right? So we will make the system to work. For that reason, we need to convert this infix to postfix or prefix. For that, they will make use of stack only. Clear? So we'll just go with the next question. So write an algorithm to check whether a string is palindrome or not using a Deque, a version of Q only. So let's take a very simple example. What is that I'm going to do? Start traversing a string from left to right, a character at a time, and insert the character in Deque as a normal queue using an insert rare. What is the one thing I'm going to take it? I'm going to take a string as a rotator. I've taken rotator, yes, I've taken rotator, and each, so this is a string I've given, okay, int input, enter this string, okay, the user Shilpa has entered rotator. Now this string we have to store it in a Deque. How will I store it? I'm going to store it in a Deque, wherein Deque is also a list only. Deque is also implemented through list only. I'm going to take one character R. I'm going to store it in Deque. And next I'm going to take O, store it. How will I store one after the other? Through append function only. Okay, I'm going to do through append function only. It's very simple. It's an algorithm only. They have not asked you the code. You can write it that only. And I'm take this T. So keep taking one character at a time and keep storing into the Deque using an append function. Deque dot append function using a for loop. Okay, I'm going to store it. I have stored in the Deque using an append function, through an append function. Append means what? That means insert at the rear end only. No, very simple. I keep inserting the elements at the rear end. I can't. For example, I got O, I will not put before R. No, I will not put like that. So that means insertion takes place from the rear end. Ma'am, what is Deque? Deque is a version of Q wherein insertion and deletion takes place from both the ends. Do you remember? I had just told you what is Deque. Deque means insertion, deletion takes place from both the end. Insertion, deletion takes place from both the end. It takes place from both the end. So here I am just inserting from the rear end. I have put everything in the Deque. What I'll do now, what I'll do means, remember here, I'm going to, okay, I'm going to remove one element from the front end. Remove, see here. Okay, remove one character. See, repeat step 1 to step 2 for all the characters and store in the Deque. Okay, insert the characters in the Deque. That I've done. Okay, through an insert, insert rate function. Insert rate function, I'm going to do that. Okay, and after that, remove this, delete front, delete rear. This I'm going to delete it. This is I'm going to delete front, delete rear, delete this, and then compare. Delete it. Compare it. I'm going to compare this. R equal to, is it matching? Yes, it is matching. And then you repeat it. Match these two removed characters. If they are same, repeat step 4, step 5. What I have to repeat in step 4, remove it again. Decrement, increment this, decrement this, increment this, decrement this. I will get O now. This is the first step. In second step, what do I get? Second step, I'm going to get O. O equal to O. Yes, O equal to O. It is true. Next, what do I do? If it is matching, repeat the step. I'm going to remove the third step. I'm going to remove this. I'm going to remove this. T is equal to T. Yes, T is equal to T. It is matching. It is matching. What you have to do? Go to the next step. Go to the next step. See here, if you're getting only one character means you can stop it. If you're getting two characters, again you will repeat it. See, repeat if they are same, then repeat step 4, step 5 till Deque is empty or left with only one character. With only one character, so you can just see here only A is left. If it's only one character, what do you do? Eventually, you just can say that string is a palindrome. Yes, it's a palindrome. Rotated as a palindrome? Definitely yes. If I write it one minute, R-O-T-A-T-O-R, I'm going to get rotator only, no? It's going to be a palindrome. So it's going to give palindrome. Is the point clear? Very simple. Take each one character and start inserting in the Deque from the rear end and keep removing from the front end and the rear end, keep matching it and keep repeating this process till it's left with one character or the Deque is empty. Okay, then we say it's a palindrome, or else we just say it is not a palindrome. If it's not matching, no, I can just say that it's not a palindrome. Not at all a palindrome. Is the point clear? So we'll just go with the next slide. Okay, we'll start with the next question. That's going to be briefly explain the working of a binary search algorithm. Briefly explain the working of a binary search algorithm. This is also a very simple technique wherein a binary search always requires the element to be sorted. Let's take one important example here and then explain to you. Okay, so let's take an example here for this. We have one binary search. So what is that we have? I'm going to take an element like 1, 2, 3, 4. Okay, I'm going to take it in terms of this so that index you should not get confused. 0, 1, 2, 3, 4. Okay, so what do I do? First thing is that you need to take in elements in the sorted way only. That's a compulsory thing that you have to keep in mind. Okay, so it has to be sorted. For linear search, it works on any sort. Unsorted, sorted, everything, it will work. For small list, linear search will be better. If it's very, if the number of elements is going to be very high, then it's going to be take n number of passes. Okay, if the element is, the worst case, if the element is in the nth position, then it has to do n number of times it has to repeat the loop, isn't it? So now, binary search, basically, it takes less number of iterations when compared to that of a, comparatively, the efficiency is going to be better when compared to that of a linear search. So we'll go for binary search. In case of binary search, the first thing is that it has to be sorted. I've taken sorted elements, and here I'm going to fix the boundary again and again, and then I'm going to search it. Now, I want to search an element, consider 10. I want to search an element 10 is present or not. In order for me to search whether 10 is there, element should be between what? Between 0 and 4. No. It has to be between 0 and 4, including both, I'm telling. It can be in 0, it can be 4 also. Between this only it should be there. I have to fix a boundary. For fixing a boundary, I'm going to take two variables. That is going to be known as beginning. And this is called as an end. So what is end? End is equals to n minus 1. That's going to be 4. And what is beginning? Beginning is equals to 0. Okay. After fixing the boundary, find out the middle element. What is the middle element? Mid is equals to beginning plus end by 2. Beginning plus end by 2. What is beginning plus end by 2? Very simple. That is going to be the index only. You have to take it, not the element. I'm not worrying about the element. I'm just refixing the boundary again and again. What is the element? Here the key element is going to be 10. Remember, keys. Which element I have to search? I have to search 10 now. So what is going to be the mid element? Mid is in mid position. Sorry, mid position. So what is that? 0 plus 4 by 2. 0 plus 4 by 2 is what? It's 4 by 2. That's going to be 2 only. Remember, you need to take a floor division. Only integer value is supposed to take it. Only integer value is supposed to take it. So I've got 2 now. I'll just check. Okay. Is or if yellow of mid, okay, list of mid is equals to key. Here we're going to get 3 cases. Is it equal to, is it greater, is it less? That's all. Is the key element greater? Is it equal? Is it less? First is equal to, greater, less. Less, greater, you can interchange it, but equal to should come first. Is it equal? Is 10 equal to 30? Definitely not the case. My element, I have to check where is it now. Is it greater? It's not equal to. Is it greater or lesser? It's already arranged. Now what do I do? For example, my search element itself is 30. If my search element is itself 30, what do I do? What is searching? Return the position. No, you will just say that return what? Mid plus 1. Okay, so we'll just continue now. If L of mid equal to key, if 30 itself is my key element, I found out. No, I just found out that 30 is in 2. Okay, return mid plus 1. That means it is the third position. Index is 2. The position is going to be third position. We found out the element. Okay, let's continue now. See here, if key, what if key is greater than L of mid? What if key is here? Students, for example, I want to search 50. That means if the key element is this side, then I have to I have checked the whole thing here from here to here. I just find out it is not there here. Means I have to search only this part of the list, not this part, because it's already arranged. It should be great. It's a greater only. No, key element, if it's greater, means I have to refix my boundary from here to here. From here to here, I have to refix. This is already fixed because it is end. What I have to refix here, this is going to be my beginning. So change the beginning. Beginning is equals to what? Beginning is equals to mid minus 1. Sorry, mid plus 1. Because mid is already checked, it should be mid plus 1. From here I have to check this and this I have to check. It is mid plus 1. If the key element is greater, you have to make beginning is equals to mid plus 1. Else, what about else? Else element is smaller. In this case the element is smaller. No, if element is smaller, what do? I am going to check. If element is smaller means I have to check from this part to this part. This is already done, sorry. Then I have to check from this part to this part. I have to check from this part to this part. This part is already fixed. This is going to be beginning. I have to rearrange this. I have to rechange this. I have to change this part. This part means what? Boundary. No, beginning. And what you should have? You need to have end only. End should be changed to what? End should be changed to mid minus 1. This is already done. I have to go for this mid minus 1. From here to here, I have to check it. It is mid minus 1. Is the point clear? Very simple. What is binary search? It works on the sorted list only. If the element is in the mid, if it's the same only, then return mid plus 1. If it's greater, beginning is equals to mid plus 1, else end is equals to mid minus 1. Just remember that. Okay, we'll go with the next question. What is there in the next question? The question is going to be, what is the key in a relational database, and explain the types of keys. So what is a key? Key is basically an attribute, a single attribute or multiple attributes that uniquely identify the tuples. For example, roll number, every student should have a different roll numbers, right? So which uniquely identify the tuples. Name can be same only, right? Name can be same only here. So each and every attribute that uniquely identify the tuples is known as a key. Any attribute which uniquely identify the tuples is called as a key. That means all these are keys only. All these things are basically uniquely identify the tuples. Then what is the difference? What is a candidate key? Means minimal attributes that uniquely identify the tuples. That means roll number itself uniquely identify the tuples. Roll number and then name, you should not take it. Only roll number itself can uniquely identify the tuples. Remember here, in case of candidate key, no redundant attribute should be there. No redundant attribute. We can just say it as redundancy, no redundancy, or minimal attribute that uniquely identify the tuples. Minimal attributes which uniquely identify the tuples, or no redundant attribute should be there. That means email itself is going to identify the tuples uniquely. Okay, that itself uniquely identify the tuples. Mobile number itself uniquely identify the tuples. Roll number itself uniquely identify the tuples. But along with email ID, you should take name. Means that name will become a redundant attribute. That's called as a candidate key. Minimal attribute that uniquely identify the tuples. What about primary key? Primary key is basically is a candidate key. One of the candidate key currently being considered as the primary key. What is a primary key? That means a primary key is one of the candidate key currently being selected. Currently been. I'm not able to pronounce this. What is this? So what is primary key? Primary key is basically one of the candidate key currently being selected to identify the unique tuples. Currently to identify the unique tuples. Is the point clear? So what I'm trying to tell you, a primary key is candidate key only. One of the candidate key that uniquely identify the tuples. Many are there. Email is there, mobile number is there, roll number is there, register number is there, student ID is there. Many are there that uniquely identify the tuple. One among them is currently been selected to uniquely identify the tuple. That is called as primary key. What is composite key? A composite key is basically a key wherein minimum 2 attributes should be there that uniquely identify the tuples. For example, in your textbook only they have given one example for the attendance table wherein they had an attendance date. Attendance date is there. Student name is there. Student roll number is there. Roll number, and then we have a status, attendance status. Okay, attendance status means what? Either absent or present. Okay, so attendance date means what? It is today's date. So we'll just take today's date. That's going to be 18 to 2026. Okay, so what is the roll number? 1, 2, 3. Attendance is going to be, status is going to be absent. He's absent. Okay, then I'm going to take it 18 to 2026. Okay, I'm going to take his 1, 2, 4. He's present. Is the point clear? The dates can repeat. The dates can repeat. What about the roll number? For example, I just want to know the same person on 17 to 2026. What is the status? Maybe he is absent. Absent for 2 days. Okay, so that means the attendance date can repeat. Student roll number also can repeat. That means which one to select? Composite. 2 attribute you should take it to identify the tuples uniquely. That is what composite primary key. What is what is foreign key? The keys which link, establish. What I can tell you for a foreign key. A foreign key is basically the attributes which establish a link between the 2 tables. Okay, there is a table called in student. There is another table called in guardian. There is a table called student. There is another table called guardian table. So in this, these 2 are different tables. Using a student table, I should be able to retrieve the student table is there, guardian table is there. Using student table, I should be able to retrieve the guardian table. Using guardian table, I should also be able to retrieve the student table. Student details, I mean to say here, that means there should be one key which creates the link. That creates a link between the two tables. It establishes the relationship between the two tables. That's what they've given here, I think. Okay, so it is used to establish a relation between the two tables. That means here in the student table, I can have something called as a guardian ID, which acts as a foreign key. And whereas a guardian Jew ID is basically primary key for this guardian table. In this, it is a foreign key. It is a foreign key. In this, it's going to be primary key. It's a foreign key. Here it is going to be acting as a primary key. This is the concept for the foreign key. Foreign key means establish a link between the tables. And foreign key should always be a primary key of another table. This table should be filled. Only this table should be created. Or else you will not have GUID only, no? That you should keep in mind. We'll go with the next question. Define network topology and explain star and bus topology. So what do you mean by topology? Arrangement of computers and other peripheral devices in the network. Okay, for the exchange of information or for stating of resources, all those things we can tell, right? What is the purpose of the network? What is the purpose of the network? What is a topology means connection of how these nodes are arranged in the network, how the nodes are arranged in the network. Okay, for sharing of resources. That is what you mean by topology. What are the two types of topology we can have? We can have a bus topology and we can have a star topology. A bus topology means what? We can have a bus or a backbone here. We have a central backbone. Using this central cable, all the nodes can be connected here. All the nodes can be connected here. If one node sends a message, all other nodes will be received. For example, I'll just tell that Ram receives dinner, Ram got first prize. And rest of them, Shyam is there, Krishna is there, Keshav is there, Radha is there. Everyone is able to hear that. Only Ram got the prize, but rest of them are able to hear the message. Here the data travels in both the direction. It's going to be bidirectional. Here data travels in both direction. That's going to be, it's bidirectional. And in order for the messages to get transferred between the ends only, we have something called as an terminators also, so that without the messages should not bounce back in the same cable, right? It should observe. Once it has reached the end of the transmission cable, the terminators will observe the message or the signal it absorbs. Okay. So it's going to be a disadvantage is what is a central cable fails, the entire network fails. That you have to keep in mind. And we'll go for the star topology. A star topology is what? We hear the concept of central device comes into picture. That means any node it has to communicate via this only. I am the boss here, you have to listen to me. Only through me or ask me. Whatever, any doubt also you have to ask me through only. Not point-to-point communication. It's a point. Through one way I can tell it's a point-to-point communication only, but it's point-to-point communication with respect to the central device, not between the devices. Central device only it has to communicate. A point-to-point communication with the central device, I can tell you. Is the point clear? Any node should communicate via the central device only. Okay, that central device can either be a hub or a switch. Is the point clear? Is it efficient? Of course it is efficient, very fast and easy to troubleshoot also. For example, if there is a particular node it is failed, no problem. Rest of the network can function easily. If one node failed, identifying that particular faulty node is easy. But whereas if the central node fails, the entire network shuts down. That you have to keep in mind. We'll go with the next slide now. What are the properties of the radio wave transmission? It's very important that you remember some of the key points here. What is the range of that? 3 kilohertz to 1 gigahertz. Okay, it moves in all direction. That's going to be an omnidirectional and radio wave frequency. And in this frequency, it can travel long distance, susceptible to interference. And in this frequency, 3 to 300 gigahertz, it can penetrate through the walls. And remember here, they're used in AM, FM radio, television, and cordless phones also. Some 5 points you have to write it in order to fetch 5 marks. We'll go to the next question. Explain the methods of malware identification used by the antivirus. In case of malware identification used by the antivirus, remember here students, signature-based detection. In case of signature-based detection, there is something called as virus signature database. What is that we have? We have something called as a virus signature database. It's a file. Basically, it consists of the patterns, all the viruses, whatever we have, all the malwares, whatever the patterns it's following, everything, all these patterns are stored in one file. That file is called as virus definition file. What is that file? That file is known as virus definition file. So in this, it is going to check that whatever the malicious susceptible file is there, that file is going to be cross-verified, or it is compared with this virus definition file for the patterns. Is it matching? If it is matching, antivirus software is going to say that yes, there is a virus, there is a virus, yes, there is a virus, it will say. Okay, then we have a sandbox detection. In case of sandbox detection, for example, some person enters this campus, some person will come to your home. Will you just let the person, or will you peep into that small hole and then check? You're going to scan? No, you're going to scan that person before he enters. If it's an unknown person. Similarly, what do we do before actually running that entire susceptible file into your actual system? We run that particular susceptible file in the virtual environment. Run the susceptible file or suspicious file in the virtual environment called the sandbox, and there we are going to observe their behavior before running into the runtime system. Before running into the actual system, we just check the behavior. Where? Not in the actual system, some other place. That means in virtual environment, that means in the sandbox. We're going to check it, we're going to observe the pattern, and then only we're going to make to the, and so we are safe. In this way we are safe. It is not running in the same system, right? It's more safe, secured way. Data mining techniques. In case of data mining techniques, we're going to use a machine learning techniques to analyze the file behavior and classify it as unsafe or malicious. That means so many machine learning techniques are there. Supervised learning, unsupervised learning, reinforcement learning. All these different techniques are used, and then based on these techniques, we can just say whether it is safe or whether it is going to be a malicious one. We can make the conclusion here running the machine learning techniques. What is heuristic detection? In case of heuristic detection, we're going to check the entire susceptible file source code. Entire susceptible source code, we're going to check it. Okay, we're going to check the entire program's code and then behavior to find out, is there any behavior, any new virus has come, any unknown virus has come that match with the similar ones. Okay, it is going to entire file, entire source code of the susceptible file will be checked. Okay, is there any new virus is there, unknown virus is there? As such, it is going to check with the one similar ones already what is there. No, it is there, any such pattern is there or not. It is going to, entire code will be checked here. Okay, that is called heuristics detection. What is real-time protection? Real-time protection is the best, safest method. What do we do? Always, see, this is the best one is before letting into the actual system only you're checking. Okay, I think the best one is going to be the sandbox detection only. Before running into the actual system only we are doing it. And next comes this going to be the real-time system. Real-time protection means what? Every time keep running that antivirus software in the background. Every time keep monitoring. Continuously monitors the running programs to detect and block the suspicious activities instantly. Background is antivirus, anti-malware, not actually antivirus, anti-malware word, you should use it properly. So, but more commonly we started using antivirus only. So this is always been run and monitors for the any kind of virus is there. If any such suspicious activities is there, means we're going to block it immediately. So these are the malware identification used by the antivirus. We'll go with the 5 markers. It's going to be the HOTS, higher order thinking skills. We'll go for these 3 questions now. Write the process to sort the following elements using the insertion sort method. So insertion sort method, so you have to show it in the representation way only then you will be able to fetch the marks. Okay, I'll just take the same example in the coming slide. 1 minute, just give me a time. So 80, 60, 20, 40, 80, 60, 20, 40, 50 and 10. Okay, this is going to be an insertion sort. I'm going to write it the way, they have given in the textbook, the algorithm, okay, the program. It's not done based on swapping. Ma'am, you could have easily explained in this only, but I have not explaining in this because they've used a concept called swapping. Swap, swap, swap. But in the textbook, swapping is not done. So only I've included this slide to show that in the textbook they have shown as swapping, but it is not done the swapping method in the algorithm, and in the textbook they have actually shifting of values is done there. Okay, we'll go with the process now. So what is this? This is going to be an insertion sort. Insertion sort, remember here, we're going to take one element at a time and then keep comparing the elements, and then we're going to compare the elements in a reverse direction. Not in the forward direction, but we check the elements in the reverse direction. Remember, we need to make use of two loops here. One is going to be I is equals to 0 to n, and then what is the value of j? J is always equal to I minus 1. And what are the other points you have to remember here? We will make use of temporary variable, and temp in this case I'm going to shift it to L of j, and always j should be greater than or equal to temp, and remember temp should always be less than L of j. Okay, these are the conditions you have to remember. Okay, so we'll just check now. So what do we have? I've just taken some elements here, 80, 60, 20, 50 and 10, and then I've just taken two loop. One is going to be I loop, another is going to be the j loop. I is fixed for all the sorting techniques. That's going to be 0 to n. In case of j, that will be starting from reverse direction, I told you. So that's why I've taken the value of j is equals to I minus 1, and then it's going to be always reverse, means it should stop till 0 only. It should not go to minus 1, minus 2 and all. That's why the condition is between j greater than equal to 0, and I should compare, each element is compared with L of j, temporary variable I'm taking, and then this is called what? This is shifting of elements. Okay, so I'm going to do this now. This is going to be considered as t now. This is going to be considered as t here, and this element I have to compare with what? L of j. I just told you what I have to do. Temp should be less than L of j. I don't know whether you're able to see or not. Temp, is it less than L of j? That means, is it 60? See, first thing I have to check. No, first thing is that what? I have to check with, I have only one element now, 80 is there. So 80, I have to check with what? L of j. J is what? I have to do j is equals to 0 minus 1 equal to minus 1. What is there in minus 1? Nothing is there. So that means first element is always sorted. In that way I can consider. There are no elements for me to compare. So it is already sorted, like that I can compare. The first time the loop doesn't run. You can take it in that way also. Okay, after that, next what happens? I'm going to consider these two elements, 80, 60, 20, 50 and 10. I'm going to take it. This is going to be I equals to 1. In case of I is equals to 1, what is the value of j? Remember this point, this is always, I'm going to take this value again and again. What is the value of j? J will be equal to what? 1 minus 1, that's going to be 0. This is going to be t now. This is going to be t. So I'm going to compare this 60 with 80. Okay, this is going to be 0. These two are compared. Is my temp less than this? Yes, it is less. If it is less, what do? I keep shifting the elements. How do I shift the elements? 80, 80, 20, 50 and 10. Okay, decrement the value. I told you reverse comparison. Reverse comparison means j should be decremented to minus 1. So now I have to compare this 60 with 60. You compare with minus 1. What is there in the element minus 1? Nothing is there. You stop it, and then now what do? I'm going to store the value of t. 60 you store it in L of j plus 1. Okay, store it in L of j plus 1. Sorry, store it in L of j plus 1. What is j? J is equals to minus 1. Minus 1 plus 1 means what? L of 0. Store 60 in L of 0. Store this 60 in L of 0. Clear? So I'm going to store 60 here. 80 comes, 20 is there, 50 is there, and then 10. Now I'm going to consider I equal to 2. When I equal to 2, what is the value of j? J should be I minus 1. J is equals to 2 minus 1. That's going to be 1. This is my t now. This is my t. Compare with these two. Is 20 less? Yes, it is less. You have to shift the elements. 60, 80, 80, 50 and 10. Okay, I've shifted. Next, this will be decremented. J is equals to 0. This 20 should be compared with T. T is what? 20. 20 is less than 60. You have to shift the elements. You have to shift the elements. That means 60, 60, 80, 50, 10. This is how it happens. Next, what is J? J becomes minus 1. Is there 20 I can compare with minus 1 element? No element only. I have to stop it because J should always be greater than or equal to minus 1. J should always be greater than or equal to greater than or equal to 0, because element stops at 0. It will not reach minus 1. Reverse comparison we are doing. So that's why it has to be till 0 only. Is the point clear? So what do? I'm going to stop at this point and store the value of 20, that is T. You store it in L of J plus 1. I told you T should be stored in J plus 1. 20 you store in J plus 1. What is J? Minus 1 plus 1 means what? L of 0. 20 you store it in L of 0. That means 20, 60, 80, 50, 10. Okay, 20, 60, 80, 50 and 10. Next, what do? I'm going to select this. This is going to be my T. This is going to be my T, and this is going to be I is equals to 3. I is equals to 3. And what is this? This is going to be I is equals to 2. Compare 0, 1, 2. Compare 50 and 80. 50 is less, shift it. So that means 80, 80, this remains the same. That means these two are arranged. 20 was, see here, you can just observe here, 60, 80 already arranged. 20, 60, 80 already arranged now. Now what do? I'm going to compare 50 and, so this becomes J equal to 1. This becomes J equal to 1. So I'm going to compare 60, 50 and T. 60 and 50. 50 is less only, no? I shift the element. That means 20, 60, 60, 80, 10. Clear? After that, what do? It will be J equal to 0. 20 is compared with T. What is T? T is equals to 50. 50 you compare with 20. What will happen? Now you have to compare, sorry. I did only know. I think I made a mistake now. I made a mistake. 1 minute. Let me erase this part. Little bit I'm going to erase this. Yeah. So 50 and 60 is compared now. 50, 60 when it is compared, 50 is less. 50 is less means no problem. What do? I'm going to shift this. This part was right only. Okay, this part was right only. 20, 60, 60, 80, 10 I'm going to do it. And what is the value of J? J is equals to 0. 50, 20 it is comparing. This part only I have to do it. 20, 50. 20 and 50 I have to compare. 50 means it is stored in T. No, 20, 50 you compare it. Once I compare, what it happens? T is not less. You can just see here. T is not less. 50 is greater. 50 is greater than 20. When 50 is greater than 20, what I have to do it? I have to stop it. Directly go for this part. Directly go for store T in L of J plus 1. Store T in J plus 1. What is the value of J? J is equals to 0. That means 0 plus 1 means what? You store T. T 50 you store in 1. 50 you store it in 1. 1 means what? Store 50 in 1. 1 means this. 20, 50, 60, 80, 10. Is the point clear? Now what happens? I'm going to store this as T. So this is done. Okay, I'm going to store this as what? I is equals to 4. I is equals to 4. Now what do I do it? This will be J is equals to 3. J is equals to 3. I keep shifting the elements. 80, 80, 50, 10 and 80 I'm going to compare. When I compare 80 and 10, definitely have to shift it. What will happen? It is 20, 50, 60, 80, 80. After that, J is equals to 2. What is in 2? 2 is equals to 60. 60 you compare with T. That means 60 and 10 I have compared. What is the value of T? T is less only, shift it. That means 20, 50, 60, 60, 80. Okay, and what is the value of j? J is equals to 1. That means 50 and 10 you compare it. Yes, 10 is less. You shift it. That is 20, 50, 50, 60, 80. Okay, and again I'm going to compare it. J is equals to 0, 20 and t you're going to compare it. Yes, 10 is less than 20. You shift it. 20, 20, 50, 60, 80. Next, j is equals to minus 1. J is equals to minus 1. J is equals to minus 1. There is no element for me to store it and compare with t with 10 with minus 1. There is no element. Stop it and store the value of t in L plus 1. L of j plus 1. What is j? Minus 1 plus 1, that means 0. L of 0, you store it. What is t? That means I'm going to write it here. Students. So what I'm going to write it here. So I'm going to put here 10. I'm going to store it in L of 0. 10, 20, 50, 60, 80. This is how we're going to do it in case of insertion sort. This is how it is given in the algorithm also, program also, everything. Shifting of element is taking place, not the swapping. Is the point clear? So we'll just go to the next slide. So swapping and all they have shown here. I've not shown the swapping because swapping is not there. Okay, it is only shifting. Okay, we'll go for the next question. Consider the marks scored by the students in a subject given 90, 80, 70, 95, 95, 85 and 80, and you're supposed to find the statistical technique for finding the range and the standard deviation. Range is going to be what? Highest value minus the lowest value. That's going to be 95 minus 70, and this is going to be the range. What is the standard deviation? Standard deviation is going to be what? The formula, you need to use it. Okay, see here, mean you need to find out. Use the mean. See, you need to find out calculations. You should be very thorough, and there will be a definite one question from this part. Please ensure that you write the formula and do the calculations. Don't do silly mistake here. Okay, so you need to use the formula here, and you can just use the formula here, and you need to append all the values here, simple calculations, and you need to find out the standard deviation, square root. Make use of the calculator. Simple calculators are allowed here, and 8.45. And there was one question, batsman A and batsman B here. The standard deviation, if it's going to be more value, means batsman with respect to the batsman concept, I'm telling, batsman 1A has a certain standard deviation, batsman B has a certain standard deviation. The standard deviation, if it's more, means it's going to be less consistent. The variance is going to be more. Okay, it's it is dispersed in a, what I can tell you. Okay, the variation is more. We should have less variation. No, we should not have more variation, right, from the mean value. That is what you mean by standard deviation. So the standard deviation means less, means it's tightly clustered. Tightly clustered means the consistency is more. Okay, just know this particular problem properly. Okay, write appropriate SQL query for the following question. So we have a table here, the student name, marks and the phone number. You're supposed to add a constraint primary key for the student register number. Very simple. They've already created a table. You need to add a primary key later. I think you already know how to add the primary key in the table itself. Okay, just after defining a column, you can have a primary key, comma, that's all. In case of adding a constraint after the table, means you need to make use of an alter command. Alter table name, add primary key. Space should be there for primary key. Register number, student register number. Okay, you need not have to give in parenthesis. It's optional. If you want, you can give it. Put it in parenthesis and semicolon. Okay, find the average mark. There is a function only called AVG here, not average, AVG only. Select AVG marks from student. Remember that AVG, you have to write it. Add 5 marks for students with the student register number 001. I have to change the marks of the student. Karthik marks, no, 94 is there. No, I have to make him correct only, no. So I have to make him 99. See here. I have to make him 99. That means I have to change the marks. Data manipulation. Data manipulation means what? Data modification. Modification means what? Delete, insert and update. Which one you use? Update. Now update table. Whenever an update comes, set will come. Update table set Marks equals to what? Marks is equals to his marks. Marks plus this marks plus 5. Marks plus 5 for whom? Only for Karthik, not for everyone, only for Karthik. Where student register is equals to STU_001, he has given in quotes. That means the data type of this is going to be varchar, remember. Okay, it's going to be character as well as number, so it should be in varchar only. That's why they've given in terms of a single quote semicolon. Display all the records in the order highest to lowest marks. That means this has to be arranged in highest to lowest. Very simple. I have to use an order by clause. Select star from student. Order by space will be there. Marks DESC, descending order, DESC of the right. After that, remove all the records of the table whose marks less than 93. Remove the tuples. No, delete from table where marks less than 93. Delete from student. Name of the table is student here. Delete from student where marks is less than 93. Is the point clear? And that's all for the session. I think we have done with all, and thank you so much. So we'll wind up the session. Thank you.